This is C340 hydraulics, and this is group 2 again. And now we're solving problem 2.52. Basically what we have here, we have a piston that has an area of 0.7 meters squared. So this is what's given to you. An area of 0.07 meters squared. This first height is 60 millimeters, and it basically goes down, and then it gets smaller until it gets to this the mercury. So this is all water, and then you get to the mercury when it gets to here, and the mercury rises a height of 100 millimeters. Right. So we have the other two givens are the gamma of mercury, so the density, and the density of water. Those are found in the table in the front of your book. So these are the givens, and from here, Glenn will show you how to solve this problem.
Alright, to start out with, we're going to call this PP for pressure piston. And we're going to call this on PO for P open. This pressure and this pressure are open to the air. So that would be 101.3 kilopascals. This right here is force P, but we're going to call this pressure PP for pressure piston. To start out with, we have P open, which is equal to P piston plus the force over area of the piston plus the difference between here and here, the height of the piston to the height of the water. We can go straight over to here. So that distance is h, and it's going to be a plus because it is going down, and that's going to be the specific gravity of water times the height h1. Then we're going to subtract the difference in mercury, which is going to be specific gravity of mercury times the height h. We get P equal to 889.8 newtons.
So the gist of these problems, if you're given a basin here and you have pressure going through the tubes, and one end is open, at least one end is open, is basically if you change your elevation, delta Z, then the pressure is going to change, and it changes with respect to how much the delta Z changes. So like in this case, it goes down a value of H1, and so it's going to be, if it goes down, the pressure is increased as it goes down, and so basically the pressure equals the height change, the elevation change, times your density. So by doing this, and you can go all the way across any of the liquids if they're the same elevation. So that is the gist of these problems. We gave you 2 examples. Have fun with the rest.